Hello everyone, welcome to DrZ Academy. In today's video, we are going to move on to the next section. It's called Bayes formula. Okay, so let's start. Now let's consider firstly the definition for a partition of a sample space. Now consider this definition. Events B1, B2, Bn constitutes a partition of a sample space S if, all right, so if their union is the sample space, right? If their union is the sample space, and also what, they are disjoint, right? So for any pair, right, Bi and Bj, they are disjoint, they are mutually exclusive. Then we say it is a partition. Okay, things like, okay, so this is the sample space, right? So and you can have different partitions, right? Say B1, B2, B3, B4, and B5, right? So they are disjoint, right? And their union is the sample space, right? Their union is the sample space. So then we say what? It forms, these events constitute a partition of the sample space. All right, so with this concept, all right, so we can introduce the law of total probability. Now let's consider this one, right? Let A be any event and B1, B2, Bn constitute a partition of the sample space. Then we will have, right, A can be written as A intersect the sample space, right? So A is a subset of the sample space, therefore this equation holds. And since B1, B2, Bn constitute a partition S, right? So the sample space is the union of these events, right? So we have that, okay? So, and then using distribution law, right? Distribution law, and then we have this one equals A intersect B1, union A intersect B2, union union A intersect Bn. Okay, so therefore A, all right, is the union of these terms, right? These parts, and therefore we do have what? P of A is simply the probability of these unions. All right. However, right, since B1, B2, Bn is a partition, these B1s are mutually exclusive. These Bi's are mutually exclusive. So therefore, these intersections are also mutually exclusive, right? So since they are mutually exclusive, the probability of their union is a summation of their probabilities. So therefore we have this equation, right? It equals the probability of A intersect B1 plus probability of A intersect B2, right? And plus probability of A intersect Bn. And then we apply the product rule to each term, right? So for the first one, we can write this one is probability B1 times the probability A given B1, right? And probability B2 times probability A given B2. And finally, probability Bn times probability A given Bn. Sorry, this is Bn. Okay, so this is called product rule. Yes, product rule for each term. And provided, of course, these conditions, right? Bi serves as the conditions. So we have this B, this must be true, right? Probability Bi must be greater than 0. Okay, so we have the law of total probability. Okay, so here we go. Suppose B1, B2, Bn constitute a partition of the sample space with probability Bi is greater than 0. Yes, and then for any event, this is for any event A. Okay, so we have the equation. This is the law of total probability. All right, probability of A equals, right, these terms. Each term is a product, right? So probability Bi times probability A given Bi. This is the law of total probability. Okay, all right, so let's just consider this example here. It says a company has 3 machines, A, B, and C, for making bags. It has been observed that machine A produces 20% of the total production of the bags. Machine B produces 50% of the total production of the bags, and machine C produces 30% of the total production of bags. Okay, so suppose 1% of all the bags produced by A are defective. 5% of all the bags produced by B are defective, and 2% of all the bags produced by C are defective. Right? Now, a bag is randomly selected from a day's production. Right? So what is the probability that it is defective? Okay, so now let's just say that it is defective. Let's say that this is the event, D. All right, this is the event D. Okay, so basically what we want to find is find the probability of D, right? So what is probability of D? Okay, so solution. Based on the setting, we know P of A is A produces 20%. P of B is 50%. P of C is 30%. And we also know the conditional probability rate. So the defective rate for A is 1%. So that is to say, probability of D given A is what? 0.01, right? And similarly, probability of D given B is 0.05. And probability of D given C is 0.02. All right, so we have these conditional probabilities. Now, all right, so we're ready to do so. So by the law of total probability, all right, so and another one is A, B, C forms a partition, right? So you need to know there are only 3 machines, A, B, and C. So all the products either made by A, B, or C, right? So they are mutually exclusive and their union is a sample space. So therefore, A, B, C forms a partition, right? So by the law of total probability, all right, so we have P of D equals P of A, P of D given A, right? Plus P of B, P of D given B, and plus P of C, P of B, D given C, right? So which equals, right, P of A is 0.2 times 0.01, right? So, and this is 0.5 times 0.05, and then plus 0.3 times 0.02. And then you can find this one, right? So let's use a calculator. 0.2 times 0.01 plus 0.5 times 0.05 plus, 0.1, 0.2, okay, sorry. Okay, 0.1, 0.2, 2 times 0.01 plus 0.5 times 0.05 plus 0.3 times 0.02. Okay, so I got 0.033. Okay, so that's the probability, right? So that's probability that it is defective, P of D, right? So you see that this is, this example, right? So it's a partition. ABC forms a partition. Therefore, for any event D, right? So we can use the law of total probability to solve this type of questions. Very good. Okay, so now let's consider another example here, right? So it says an insurance company may face financial problem because of a tornado hit. the probability that there will be a tornado hit is 0.1. If there is a tornado hit, the probability that insurance company faces financial problems is P. If there is no tornado hit, the probability that the insurance company faces a financial problem is P over 10. All right, so it is known that the probability that the insurance company faces financial problem is 0.55. So find the value of P, right? So find the value of P. See, let's consider this. There is a tornado. Say that this is T, all right? So there is no tornado. That's going to be T complement, right? It's going to be T complement. So we know that there is a tornado hit is 0.1. So we know that P of T is 0.1. So P of T complement is going to be 0.9, 1 minus 0.1, right? And also we know the probability, if there is a tornado hit, the probability of facing financial problem is P. Okay, so let's say that company facing financial problems, let's say that this is our even A. All right, this is even A. So we have P of A given tornado hit is going to be P, right? And also probability of A given there's no tornado hit is P over 10. And also you may see, right, T and T complement forms a prediction, right? So you see that, right? Either that has a tornado hit or no tornado hit. So T and T complement forms a prediction, right? So therefore, by the law of total probability, all right, so we have what? P of financial problem equals P of T, P of A given T, plus P of T complement, P of A given T complement. All right, so this one equals P of T is, as we see, that's 0.1 times P, right? So, and plus, all right, so 0.9 times P over 10, right? So, which equals what? 0.19 times P. Now, this one equals what? 0.55, as we know, right? So this is given 0.55. So now P equals 0.5. Okay. What? 0.1 0.19 times P. This is not a good problem, right? Oh. Instead of 5, let's say this is 0.5. All right, let's say this is 0.5. Okay, so 0.05. So P equals what? 0.05 over 0.19. All right, so that's going to be 5 over 19. Okay, 5 over 19. All right, sorry, this should be what? Cannot be 0.055. All right, so that's too much. It should be 0.05. Let's say that. All right, 0.05. Okay, instead of 0.55, let's use 0.05. Okay, sorry about it. So this is 5 over 19. Okay, very good. See, this is also, you need to realize that T and T complement is also a partition of the sample space, right? So after reading that, using the law of total probability, you can solve this one. Very good. Now we're ready to do the Bayes formula. All right, the Bayes formula. So it assumes that B1, B2, Bn constitute a partition of the sample space with probability Bi is greater than 0. Then for any event A with P of A is greater than 0, and any I we have, all right, so this is given here. Okay, this P of Bi given A equals, on the top, probability Bi, probability of A given Bi over probability of A, where P of A equals this one, right? This is actually the total law of total probability, right? So now let's just prove this one, right? So it's pretty easy to prove. This one equals, all right, by the definition on the top, Bi. Bi intersect A over P of A. So you can see this one on the top using the product rule, right? So it is probability of Bi times P of A given Bi. That's the product rule. And over the bottom, you can use this one, right? The law of total probability, right? So you can put there. So therefore, it's good. All right, that's the Bayes formula. So what Bayes formula do? Okay, so here you have these probability of Bi, right? So these are called prior probabilities. Probability. And also you have probability of Bi given A. This is called posterior probability. Okay, so you have prior probability, you have posterior probability. Now, Bayes' theorem is to find the posterior probability. Okay, so it is given even A has occurred. Now, what is the probability of Bi? Right? So that is we know the prior probability of Bi, right? So that's the prior probability. But now if we know some additional information, say A has occurred, then what is the probability of Bi given A has occurred? It's like updating the probability of Bi. Yes, and since what? Additional information is given. So that is what Bayes' formula does. Is what? Updating the probabilities given the event has occurred. Yes? Okay, prior and posterior. Okay. Now let's consider this example. Okay, suppose an election poll is taken in 3 states. In state A, 50% of voters support the Liberal candidate. In state B, 60% of the voters support the Liberal candidate. In state C, 35% of the voters supports the Liberal candidate. Among all the participants in the poll, 40% live in state A, 25% live in state B, 35% live in state C. Given a voter, all right, so now it's this thing, right? So given a voter supports the Liberal candidate, now what is the probability that this voter lives in state A? Okay, so now let's just define this event is going to be our event B, all right? So this voter supports the Liberal candidate is event B. No, not event B, right? So support the Liberal. Let's say that is going to be L, okay, even L, and state A is from lived in state A, that's A, lived in state B, that's B, lived in state C, that's C. All right, so there are only 3 states, so A, B, and C forms a partition for all these voters, right? So solution. Here, A, B, and C constitutes a partition. All right, constitute a partition. Now, hence, right, by Bayes formula, right? So we have what? Probability of, right, leave state A, right? A given supports the liberal candidates equals what? Right, P of A times P of L given A. All right, on the bottom is actually the law of total probability, right? So P of L is P of A, P of L O given A, plus P of B times P of L given B, and plus P of C times P of L given C. All right, so this one equals, all right, so now let's start. P of A is state, lives in state A, that's 40%, that's 0.4. And if it's living in state A, 50%, so times 0.5. Right, so that's the conditional probability. Now here is again 0.4 times 0.5 plus B, right? So 25 lives in state B, 0.25. Then in state B, 60%, right? So that's 0.6. And plus state C, that's 35%. In P of C is 0.35, and then in C 35%, yeah, and times 0.35. Right, so now let's say that this one equals, right, just use the calculator, right? So it's 0.4 times 0.5 over in the parentheses, all right? So be careful in the summation in the parentheses, okay? 0.4 times 0.5 plus 0.25 times 0.6 plus 0.35 times 0.35. Close the parentheses, and here we go. We got this one is what? 0.423. If we round to 3 decimal places, right? So now we have this P of L given A is 0.4233. Now, let's just consider this one again, right? So now you have, you do have P of A is what? 0.4, right? So 40% lives in state A, right? P of A is 0.4. And however, if I know this voter supports the liberal candidate, this condition is additional information. Now the probability of the voter lives in state A became what? 0.4233. See, this is the Pereira probability, right? And this is the posterior probability, given that the voter supports the liberal candidate, right? Now the probability of A became 0.42333, right? So that's what we have for the Pereira and posterior, the Bayes theorem, or Bayes formula, okay? Very good. Let's consider another example here. Say 100 men and 120 women live in an apartment building. It is known that 3% of men are smokers and 20% of women are smokers. suppose a person is randomly selected from them. What is the probability that the person is a woman, given that the selected person is a smoker? Okay, so let's say smoker, right, say this is A, right? So man, it is a man, so it's women, that's female. Okay, so now we have what solution here. So apparently M and female constitutes a partition, right? So, and also we know the probability of A. Okay, so probability of M equals what? Okay, 100 million over the summation is 220, right? So which is what? 5 over 11. And the probability of female is 120 over 220. That's a 6 over 11. All right, so, and also we know the P of smoker A given M equals what? 30% of the men, that's 0.3, right? And also probability of A given female, that's what? 0.2. Okay, very good. All right, so now we have the probability. What do we want to find, right? So it's a woman, a female, given A, right? So by Bayes' theorem, right? So let's say by Bayes' formula, right? So this equals all right, on the top is probability of female P of A given female. Over the bottom, probability of female P of A given female plus P of male P of A given male. All right, so we have this one plugging in all the values here, right? So we have female is 6 over 11 times 0.2, right? So, and this is a 6 over 11 times 0.2 plus 5 over 11 times 0.3, right? 0.3. Okay, so now this one equals, right? So you can just use a calculator. Okay, here. Okay, so 6 over parentheses. All right, so I got this 0.4444. Okay, that's what we get. Okay, so that's the conditional probability, right? So now you can see that the per probability, initially probability is a female equals what? 6 over 11. Now if you want to have the okay, 6 over 11, the decimal points is equals 0.5455. Okay, 5455. And now after I know that it's a smoker, given smoker is what? 0.4444. Okay, so now you can see, right? So this is the Bayes theorem. Yes, so you have a prayer probability for it's to be a woman is 0.5455. Now, if I give some information, additional information that this selected person smokes, right? So the probability that it's a woman became what? 0.4444. Okay, it's like updating the probability of female, right, of a woman, given some additional information. That's what Bayes' theorem did. Okay, so very good. All right, that's about the Bayes formula. All right, thank you for watching, and if you like this video, please smash the like button and leave a comment. Let me know how you think about this video. And if you think this video is beneficial to some your friend, please feel free to share this video to them. And I really appreciate your time, and thank you very much. I will see you in the next one. Bye-bye.